So good afternoon, everybody, and thank you very much for inviting me to present some of my work in this Neurobinar. Today, I'm briefly going to present some of my background and my work as a PhD student before presenting my current project as a postdoc between the LNC in Saint-Charles and Boarding Ring in Toulon. So I started by studying philosophy and science in Paris. And this is where I got interested in philosophy of mind and cognitive science, so that I decided to study neuroscience. I did my master's degree in Marseille, and it's at this time that I got the opportunity to participate in the Patent Shaker Startup Initiation Week organized by Neuroschool. I must admit that these events made me reconsider some prejudices I had about the private sector and got me quite interested in small companies. So then I decided to continue studying neuroscience in Marseille while keeping an interest for small companies. I did my PhD in Marseille and also got another position. This work, my research during this time was supervised by Christophe Lopez in the LNC. And we worked on self-location. Self-location is an aspect of the body, of bodily self-consciousness, and it corresponds to the fact of feeling to be located somewhere at some point in time. For example, at the moment, you probably now feel located within the physical limits of your body and not floating near the ceiling. This is because your brain uses sensory inputs to locate yourself in your body. For my PhD, I focused on the vestibular contribution to self-location. But we were also interested in the integration of vestibular information with visual or interoceptive signals from the viscera, for example. To approach all these questions, we used an innovative approach by combining paradigms from social neuroscience with vestibular electrophysiology techniques. I used virtual reality and developed a new measure of self-location in VR. And we studied healthy participants, but also patients with vestibular disorders. Nearly all these topics and skills match the interests and activities of a small company I discovered in my hometown called Boarding Ring. I got in touch with them during my PhD and learned a bit more about their solutions against motion sickness. When I heard of the existence of the Neuroschool postdoc fellowship to work with a private company, we found that this was a perfect opportunity to initiate a partnership. They were working on a new solution to fight against cybersickness, the equivalent of motion sickness in VR. And they could use some help from someone with experimental skills related to multisensory information and virtual reality. So here I am working on cybersickness with Boarding Ring. As motion sickness, cybersickness is characterized by feelings of dizziness or nausea, for example. It generally occurs during exposure to a moving virtual environment while you are still, with little or no movement from the user. These effects dissipate when you stop the immersion in VR, but they can last for several hours. Cybersickness is mostly considered to originate from sensory conflicts. When a user is immersed in VR, visual information may indicate self-motion, while other sensory inputs, such as the vestibular and somatosensory signals, indicate that you are sitting or standing still. Moreover, an optical flow can create an illusory sensation of self-motion called vection. Vection can facilitate cybersickness, and its intensity may be an indicator of the onset of cybersickness. Another theory proposes that postural instability favors cybersickness. Studies showed that individuals with higher postural instability measured before the exposure to VR are more sensitive to visual simulation of self-movement. According to this theory, spontaneous postural instability should predict susceptibility to cybersickness, and its onset should be preceded by an increase in postural instability. To fight against cybersickness, Boarding Ring created the Symmetric Vr, an electronic device that aims to restore visual vestibular congruency in VR. Two displays are placed in the lateral visual peripheral field, and they show a grid of dots moving according to the user head movements and its position relatively to gravity. These visual signals reproduce movement of the image on the retina that would occur during natural self-motion in the real environment. This provides peripheral visual information consistent with vestibular information and other signals related to head motion. A first objective of our project is to test the efficiency of the Symmetric VR against cybersickness. A second objective is to test the theories of cybersickness using this device to restore visual vestibular congruency in VR. To do so, we will conduct a series of experiments using virtual reality and the Symmetric VR. Participants will be immersed in VR and exposed to a virtual roller coaster as the one you can see here on the screen. The exposure will last 10 minutes. We'll have 3 experimental conditions in which the Symmetric VR will work in different modes. In the off condition, the Symmetric VR is simply switched off. It will therefore not deliver any peripheral visual information. When it will be turned on, dots will appear on both screens on each side of the participant's head. In the on condition, the Symmetric VR will function normally. The dots will move according to the movements of the participant's head to provide visual peripheral movement information congruent with the head motion. We also developed a Sham mode. In this mode, the dots move randomly. This mode aims at controlling potential distracting visual effects that would have an impact on cybersickness. Each condition will be presented once in a random order during 2 sessions that will take place 1 week apart. Half of the participants will be exposed to the on and off condition, while the other half will be exposed to the on and sham conditions. We will use different subjective measures of cybersickness. Once at the beginning of the sessions that will take, once at the beginning of the sessions, we will measure motion sickness susceptibility to see if this predicts the onset of cybersickness during the exposure to VR. Participants will also complete the SSQ, the Simulator Sickness Questionnaires, to get a pre-test measure of cybersickness. During the exposure of VR, every 2 minutes, participants will have to answer the so-called misery scale to indicate how they feel. And this will provide us with information about their level of cybersickness during the exposure to VR. After the exposure, they will indicate the intensity of action they felt during the immersion on a visual analog scale, and they will again complete the SSQ to get a post-test measure of cybersickness. Based on the hypothesis of a visual vestibular conflict, providing peripheral visual information congruent with vestibular information should reduce cybersickness. We therefore expect that cybersickness scores for the on condition will be significantly lower than the scores for the off and sham conditions. In addition to subjective measures, we will use electrophysiological and postural recordings as objective measures of cybersickness. In a first study, we will measure forehead skin conductance, which reflects the activity of the sweat glands, and skin temperature in the left hand. Skin conductance should increase, while skin temperature should decrease during the exposure to the virtual roller coaster for all conditions. We expect that the increase in skin conductance and the decrease in temperature will be lower for the on condition compared to the off and sham conditions. In the second study, we will use posturography to test the predictions of postural instability theory. According to it, participants with higher postural instability should be more prone to cybersickness than more stable participants. We should observe an increase in postural instability during VR exposure, evoking cybersickness. We also hypothesize that postural instability will will be reduced for the on compared to the off and sham conditions. So, in addition to this, we will also get interested in presence, which is closer to the topics of self-location I studied during my PhD study. We will analyze the feeling of presence in VR. This feeling of presence is the illusion that the virtual environment is real, so that you feel in there and you react to it as if it were your real environment. The links between cybersickness and presence are still unclear, and so we want to investigate that a bit more. And we are also interested in the effects that the Symmetric VR may have on presence. We also plan to develop clinical application with later investigation. Thank you for your attention, and I'll be happy to answer any questions.
Thanks very much, Estelle, for this presentation. I now invite you to ask your question in the question box or to raise your hand to speak.
Pascal a levé la main, je crois.
Oui, j'avais levé la main. I had a quick question. How related the motion sickness is related to the cyber sickness? So it's the same mechanism, or what do we know about that? Just overall.
Well, current theories about it propose that it's very similar, and some say that cyber sickness is a sub-form of motion sickness. But we have, the investigations have been made since several years, but we're not so sure about the causes and the real mechanisms underlying cyber sickness. Although, as I said, there are different theories that propose that it may come from a sensory mismatch between visual and other sensory information about self-motion. And there are also other propositions about postural instability that may cause it too.
Thank you. Yeah, because personally suffering from both, basically, a single treatment or a single way to alleviate both would be just fantastic. Thank you.
There is a question from Lydia Karkarian.
Yes, thank you very much, Estelle, for your very interesting talk. I didn't really understood how you will test the two different theories. So I understood for the sensory conflict theory, but how will you test the postural instability theory with your system?
Yes, I didn't develop that very much, so thank you for the question. We're going to use a very simple force platform on which the participants will stand before the exposure to VR, so we can record their natural postural instability. And so we will have an idea of their natural instability, and then we will ask them to stand up on the platform during the 10-minute exposure to VR. So we will analyze different indicators to see if first, if the participants with more instability are the ones that have cybersickness, and also for those that will have cybersickness during the exposure to VR, if this is linked to more instability during the exposure to VR. Because these are the hypotheses of the postural instability theory, but results are sometimes unclear still in the literature. So maybe we can test this, and so we can also we will use the same conditions, the on, off, and sham conditions as I described with the Symmetric Vr, to see if the Symmetric Vr, when it's on, maybe it reduces cybersickness and postural instability or not.
Thank you.
Thanks. You have a question from Eva, which is in French, but we're gonna like summarize in English. So is it possible that someone feels cybersickness from another situation?
You mean another media?
Yeah, because it's you talk about virtual reality task.
Yeah. So
she talked about simulator, IFFSTAR, video games.
Yeah, so yeah, it can be cybersickness was first called simulator sickness. So it's all the motion sickness that you can get from technology, visual displays. So it can be in VR, but it can also come from a screen, from a visual screen.
And you have a last question from Rochelle. Do you see it?
I don't see the questions.
Okay, great presentation. Merci. About feeling nausea with cybersickness, is there a lot of individual variability? Does everyone eventually feel ill, or are some people very tolerant to it? Sorry.
So there are quite a lot of individual differences. I did not do a lot of experiments for until now, but for the pretest I've done, some just don't feel anything. Some people just feel some heat, so you have body sweats, which are classicals, or you feel maybe headaches or fatigue, and some go to nausea and they feel that they are about to vomit. So there's a wide range of reactions to the exposition to the roller coaster, for example.
Thanks, Estelle.